In this video I would like to talk about another important term called buoyancy. It is due to a body when a body floats in the water or any fluid. For example, it completely submerged or partially submerged. Then the resultant force acting on the body due to the fluid is called the buoyant force, and that force helps prevent the body to drowning. It will not drown into the water. For analysis purpose, we will go and see, for example, a generalized body of this shape. Let's assume that, and this is a solid body which is fully submerged in the water. This water is under the atmospheric pressure, and for example it is height 1, and here I have the it is depth and h2. As I mentioned, the body is fully submerged in the fluid, and consider V is the volume of the body. Now let's have a look at the analysis. We would like to find the equation for finding out the buoyant force. Let's see, the body is encompassing by a cube-shaped volume of fluid, and here are the forces. F1 is force acting on the top surface of that element, this F1, and F2 is acting at the bottom of the surface of that cubical element of fluid. FB is the force, which is buoyant force, and W is the weight of fluid occupying the cube minus the volume occupied by the body. If I apply the equilibrium in the y direction, I can easily write down the equation for FB will be nothing but FB equal to F2 minus F1 minus W. Now furthermore, the F2 minus F1 is given by gamma H2 minus H1 into A, which is volume of that fluid. Gamma is the specific weight of the water or the fluid. FB then subsequently can be written as, and after performing this analysis, cancelling out the terms, and these two terms are cancelled out, and you will get this FB equal to gamma into the volume. So force of buoyancy is equal to the weight of the fluid displaced by the body. Next, I would like to solve one problem. Let's consider a buoy which is connected with a cable at the ground, and it is fully submerged in the water. Okay, so the water is kinda at this level. Now the question here is to figure out the tension in the cable. Okay, so let's go and draw the free body diagram. So here is the free body diagram of this. You see the cable is connected with the ground, and it has a tension T in it, which is needs to be determined, and W is the weight of that Y, and FB is the buoyant force acting on it. Now the force balance will provide you FB equal to W plus T, and now substituting the values will result in, now as you have seen that I have substituted the values of FB, where this gamma is the specific weight and equal to rho density and G for the water. So after substituting the values, you see that the specific weight for water is 9810 Newton per meter cube, and the volume of this Y is 4/3 pi r cube. minus the weight, so it will give you a final value of 9350 Newton. So that is the tension in the cable that you have obtained.